So good afternoon, good morning. Hello to all of you, and thank you for joining today to the webinar, Milking, Setting the Scene, Opportunities and Challenges, Trends in Different Regions. My name is Maria Sanchez Mainar. Sorry, my screen is a little bit slow. And I am Science and Technical Manager at the International Dairy Federation. And I'm just going to give some brief introduction before passing the word to our moderator. So yes, some housekeeping. We are keeping this meeting as a meeting, not as a webinar. So keep your microphone muted and turn off your video if you're not speaking. We encourage you to send us questions in the chat, and this will be answered during the Q&A later on. And if you want to, there is a button that allows you to have a live transcript of the speakers. I wanted to inform you that we are preparing, well, it's actually already open, an online event on IDF milking technologies. So we will call the IDF Milking Technology Symposium. It will take place 28 and 29 November this year, and it will be fully virtual event. We have some sessions with some keynote speakers, and we will also have some abstracts that can be presented. I think after this event, you will receive maybe the promotional email of the webinar, so you can look at the details. And registration will be soon open. As a really small fee, and we will be encouraging you to send us your abstracts. We have chosen 3 main sessions. So the first one will be about milking machine technology, design, efficiency, and testing. And we will be trying to discuss, for example, those topics that are there. We have identified already some keynote speakers. The second session will deal with dairy health and welfare in sustainable milking systems. And the third one will focus on farm management and dairy business in milking systems. Also, we will discuss the use of the data, how to improve farm management and decision making, a little bit about labor, automatic milking, etc. Today's moderator is John Upton. He's the leader of an action team that exists in IDF since a long time. It's called the IDF Team on Milking Machines and Methods. IDF has been discussing for many years about milking machines. And with this, I let John maybe introduce a little bit maybe the work of IDF and the action team, or what has been doing until now, so that you can know a little bit about it. Thank you and enjoy the webinar.
Thank you, Maria, and good morning and good afternoon to everyone. First off, I'd just like to thank IDF for organising this event, and indeed the upcoming event that Maria just mentioned. So just personally, first to introduce myself, I'm John Upton. I'm a research scientist at Teagasc. Teagasc are the Agri and Food Development Authority in Ireland. I myself work in the area of milking research, and I manage projects that involve increasing the efficiency of milking systems. As Maria mentioned, I'm also involved with the IDF through the Milking Machines and Methods Action Team. The work of this particular action team is presently focused on revising and updating the international standards for machine milking. And this work is in collaboration with a panel of experts which are assembled from a number of countries internationally. So our aim, I suppose, as part of that ISO revision is to indeed build on the excellent work that was put into the previous standards, which were published in 2007, but also, I suppose, to update the standard so that it's capable of supporting the new developments of future milking systems. So I suppose we aim to encourage innovation while also focusing on key milking outcomes. So this is a very exciting project really to be involved with. The group is, I suppose, pretty involved in the process currently. There's a number of months' work yet to be carried out before the fruits of the labour are realised, but currently there's very good engagement among the group and we are progressing well through those tasks. So that's enough about me. Now I'd like to take the opportunity to introduce the first speaker, a colleague of mine here at Teagasc, Dr. Bernadette O'Brien. Bernadette is a principal research scientist at the Teagasc Animal and Grassland Research and Innovation Centre. In her current role at Teagasc, much of Bernadette's work focuses on strategies to ensure optimum milk and dairy product quality, specifically in relation to chemical residues. This work is of particular importance in meeting the demand for premium Irish dairy products in new and existing markets internationally. Bernadette's other projects include investigating in automatic milking, precision grazing management, labour efficiency, and exploring new technology on dairy farms. Bernadette has also been successful in securing significant EU and national research funding, has published widely, and has extensive collaboration with the national dairy industry and international dairy research groups. Now I'd like to give Bernadette the opportunity to present her work today. Thank you.
Thank you, John. Now, can you see my screen?
Not yet, Bernie.
Okay.
Yep, looking good.
Okay. Okay, thank you, John, and thank you to the participants. The title of this presentation today is A Current Narrative on Automatic Milking. Sorry, the movement of the slides doesn't seem to be operating too well. So first of all, I'd like to talk about the concept of automatic milking and its increasing popularity. An increase in adoption rates of automatic milking systems is occurring in different areas globally and has done so in recent years. And that suggests a larger role for automatic milking in the future. Automatic milking continues to represent a popular option in many of the Northwestern European countries in particular, such as the Netherlands, Germany, Belgium, France, and some others as well. Much developmental and research work has been done before 1992 and since 1992 as well. That was the year that of the introduction of this technology. While earlier work has been mostly associated with the mechanics of milking, much of the current developmental work is associated with refining sensors, data analysis, software, and the like. And for example, potential exists here for the automatic or the automated separation of milk, for example, or different milk flows, which could be used, for example, for diversified value-added products and that. But of course, the challenge there would be for the sensors to be developed that would operate faster than in the past, such that they would be able to detect the milk and create the separation then based on maybe protein level or omega acids or the milk suitable for infant formula or whatever. So that is some work that could be done there. I suppose that we can say that the move to automatic milking has very much been driven by labour, and automatic milking undertakes the physical task of milking normally performed by the operator and considerably reduces the manual work. So it can mean a new order and method of management on dairy farms. Now, this slide is on labour. I won't talk too much about labour because I know Steve is talking about it afterwards, but just to mention it, a few points, and also the fact that we did a study on it in the past as well in relation to automatic milking. The milking task accounts for the majority of dairy labour, really, I suppose up to 40 to 50% of dairy labour on farms in Australia and about approximately 33% in Ireland. So it's not surprising that automatic milking is increasing in popularity. We could speculate as well, I suppose, that reduced technology costs and higher labour costs of the future could mean a more widespread adoption of automatic milking systems in that scenario. Automatic milking can replace people, as we said, in the milking parlour, and it can also reduce overall labour input on a dairy farm, as it allows farmers to take more time off at weekends, have more time available for their families, and have a better quality of life generally. So we did conduct an Irish study at Tagus a few years ago, which quantified the difference in labour requirements in terms of time between conventional milking and automatic milking operated in a pasture-based system. And this slide shows, here you can see the results, the main results of this. This slide shows the average dairy labour input in hours per cow per year for combined and specific dairy tasks on automatic and conventional milking farms, Irish dairy farms. So you can see here the total dairy labour input was reduced by 36% with automatic milking versus conventional milking. The automatic milking farmers required 15.8 hours per cow per year to do their work, whereas the conventional milking farmers required 25 hours per cow per year. Now, despite labour being reduced by 9.2 hours per cow per year, the daily end of work times were similar for both milking systems. And farmers in each of the milking systems, on average, finished their daily work at 6:30 in the evening. However, the daily start times were significantly different. And the automatic milking farms actually started 50 minutes later than the conventional milking farms. The average start time for the automatic milking farms was 5 to 8 or 7:55 in the morning. And the start time for the conventional farms was 7:05. So 50 minutes of a difference there. The adoption of automatic milking also changed the type of labour undertaken, with automatic milking farmers spending more time managing and overseeing the system rather than doing the carrying out manual labour. And much of the reduced labour associated with the automatic milking was associated with the actual milking process. There was less time being spent at the milking process. And I suppose one can understand that because the average time for conventional milking, the person has to be associated with the milking process approximately about 3 hours per day, either 1.5 hours in the morning and again in the evening, or else maybe 2 hours in the morning, 1 in the evening, depending on the milking interval and that. So the automatic milking definitely did reduce the labour impact as we measured at that time. Now, the decision to opt for automatic milking, I mean, this is up to every farmer. The decision, it needs to be taken quite seriously because there's a lot of investment involved. And it has to take into account, I suppose, the decision as to whether a person is going to adopt the automatic milking or not. It has to take into account points like, is the person likely to use the data or information generated on the farm for improved efficiency? If they're not going to use the data and the information, well, that's one thing that they're not going to be doing. On the other hand, they may want a reduced workload, as we've said, and that's a valuable option as well to go with. The cost and the availability of skilled labour can be taken into account. If there's a lot of skilled labour available, well, then the person can get that instead of maybe the automatic milking machine if labour is their issue. And but very, very significantly, they must look at the economic goals of the farm as well. We would see, I suppose, that there is a good lot of awareness about automatic milking out there, but at the same time, it's not prominent among many dairy farmers as well. And they may not be aware that automatic milking can assist the dairy sector in terms of performance efficiency, the well-being of the stock, the well-being of the manager, and the economic performance, all of which focus on sustainability of the farm. But it certainly is important. I mean, the automatic milking isn't suitable for everybody, and it is important to ensure that the operator is in tune with and understands the management required for automatic milking, both at the technical level and at the data level, and as well then as having the more traditional skills as an animal operator as well. So there's a fairly broad range of skills required. And this is fundamental because a key aspect of the system is that it allows the operator to focus on management issues, as we've said, and not spending all of their time on the operational issues. And of course, concerns do surround the profitability of the system for people as well. And this is a potential reason why the technology is not adopted more widely. But in some situations, the person prioritizes differently and they may go for the improved labor scenario, even if it's not as profitable as the conventional system. Now, of course, in Ireland, we have a grass-based system. We have a pasture milk production system, and it is somewhat different managing an automatic milking system in that scenario. Until relatively recently, the majority of automatic milking systems were installed in combination with indoor or restricted grazing systems. But grazing has some advantages, like, for example, the economics. It certainly has for us an advantage in terms of economics and also in terms of product quality. So it is important that the grazing and the automatic milking can be easily, integrated. And in this system, the grass allocation is used to encourage the cow movement into the automatic milking system. And I suppose we have tried to adopt the robot into the pasture-based system as opposed to changing our grass production system to suit the robot. So this slide shows, or it explains our seasonal pasture-based milk production system. In the top graph there, you see on the x-axis you have the months of the year, and on the y-axis you have the percentage of cows in the herd. You can see that the vast majority of the cows calve in the February-March period, and or late January, February and March. They then go into calf in the April-May period. They continue milking for up to 300 days per year. Their peak milk production is about April-May, and then they're all dried off in November and December. Then if you look at the graph underneath, you see the months of the year again on the x-axis and the kilograms of dry matter per hectare per day as being the grass feed requirement on the y-axis. So in this graph, the lower graph, you see the red line there as being the daily herd feed requirement. And obviously you can see that that is at a maximum at the same time that the milk production is at a maximum in the top graph in the same months. And you will also see the green line there in the lower graph, which indicates the daily pasture growth rate, which is also at a maximum at that time in the middle months of the year. So therefore that allows us to produce the vast proportion of our milk from grass. So at Moore Park, we have been focusing on integrating the pasture system the robot into the pasture system and trying to maintain the benefits of grazing at the same time. In that scenario, we're trying to optimize cow number, milking frequency, and grass conversion to milk. So, but there are obviously challenges. We're trying to maintain a good milking frequency and a good milking interval. We always like to have a milking frequency of about 1.8, 1.9 milkings per day. Milking interval, we don't like to see the average milking interval going above maybe 15 or 16 hours. Then in terms of the herd size, as you've seen there with the previous slide, all of the peak milk production occurs for all of the cows really in the same months, and therefore the utilization of the robot may be a bit less on the shoulders of the year. And so the the number of cows, or the density of cows, stocking density of the cows on the robot, is limited by the milk production in the middle of the year. And the second major challenge then is maximizing the output from the system rather than the cow. And we have looked at that in the past, of increasing the cow number up to maybe 85 and 86 cows, and lowering the individual milk yield, and therefore looking at the overall output from the system as opposed to the output per cow. And then, of course, grazing management is a challenge as well in this scenario. This slide just gives a brief description of the whole grass management scenario. At the top left corner, you have the picture there of the rising plate meter, and that is a key part of the thing, where we advise farmers to measure their grass at least once weekly, maybe twice weekly during the main grazing period. They put in their data into Pasture Base Ireland, which is a web-based, it's a grass database. They put in the grass heights there for each paddock, and a calculation is done to indicate then to them the herbage mass in each of the paddocks. The herbage then, from that data, then a grass wedge, what we call a wedge, that is the graph there that you see covering most of this slide, with the blue bars. And that each blue bar there represents the herbage mass in each of the paddocks, so of the farm. So the paddocks are arranged in decreasing order, and then a demand line is drawn basically from the target pre-grazing yield, which is about, on the left-hand side there, you can see it's about 1,300 kilograms of dry matter per hectare, down to the target post-grazing residual, down at the bottom right of the graph, about 50. And then you have the demand line there. The decision-making or the decision support tool of this element of this technology comes in place then, because you can see if there is a gap, or the farmer can see if there is a gap between the bar, the blue bar, and the line, then it is likely that there is going to be a deficit there that represents a deficit in feed. The feed isn't coming up to the amount that the cow requires. So then the action there is to come in with supplementation. On the other hand, if the bar is higher than the line, that indicates a surplus of grass, and that is generally taken out as silage and kept for the winter time. So that is now each farm then is divided in. We normally operate an ABC system, so the farm is divided into 3 different sections, and that scenario is done for each section each week. So the farm, the grass is managed as 3 separate farmlets in terms of the automatic milking system. And the idea of dividing the farm into the ABC system, the 3 sections, is that we can allocate across the sections for the cow. For example, if we want to give 18 kilograms of dry matter per cow per day to the cows in the automatic milking herd, they can get 6 kgs of dry matter in each of the 3 sections. And that means then that when the grass depletes in one section, in section A, say, they know there is more grass in section B, they want to travel to section B, and in doing so, they have to come through the robot. And then they have a chance of being milked. So that's the way in which the movement occurs around the farm. So the cows leave the paddock. In this slide here, we're saying that the cows leave the paddock when the grass is reduced and pass through the milking unit before moving to new grass. The concentrate supplementation that we would normally feed is only about 0.5 kilograms per cow per day in the middle of the year, generally about 400 kgs or less throughout the lactation. The farm is walked and grass measured weekly, and we have 3 grazing blocks there managed independently. And the grass surpluses or deficits can be identified by the system I've outlined. And normally the pre-grazing herbage mass that we would be allowing the cows into would be between 1,300 and 1,500 kilograms of dry matter per hectare. And that means that the cow she's not deficient in grass, so that her yield isn't affected. On the other hand, she hasn't too much grass ahead of her that she gets lazy and she doesn't want to move around the system. Now, the effect of milking frequency and concentrate, just want to focus on this. We've done a recent trial on this last year. And I mean, there are obviously, there are various management strategies such as milking frequency and concentrate supplementation. And these have been examined before from the point of view of output from the automatic milking system. The relationship, between milking frequency and concentrate supplementation is complex, particularly in the seasonal system or pasture-based system. Due to the limited time available for milking on an AM system, for example, 23 hours per day, an increase in milking frequency or an increase in milk yield can put downward pressure on herd size. So the parameters of milk yield, milking frequency, cow number, and concentrate supplementation need to be examined individually and at an interactive level. So, like I referred to previously, would a similar output be achieved from a smaller herd size, where cows are milked more frequently, as from a larger number of cows milked less frequently? So we looked at this experimental trial in 2022. Our research question was, how does milking frequency and concentrate supplementation affect milk production with an automatic milking system? And what is the interaction between both of them? This trial ran from May until September of last year with 68 cows, on average 54 days in milk, and the cows were randomly assigned to 4 groups. We had a free and restricted milking permission, which allowed milking after 6 to 8 hours or 12 to 14 hours from the previous milking. And we had a low and high concentrate supplementation level, 0.5 and 3.5 kilograms of concentrate. So we had free milking permission, high concentrate, restricted milking permission, high concentrate, free milking permission, low concentrate, and restricted milking permission, low concentrate. Now, from this slide, you can see, or well, first of all, cows with a free milking permission and high concentrate had a higher number of milkings per cow per day and milk yield per cow per day. But that was to be expected. So nothing major there, but this slide now, or this graph, shows you the milk yields per cow per day across the experimental period for each treatment, each individual treatment. And you can see there that the milk yield per cow per day over the experimental period was similar for the yellow and the purple line. That is for the cow groups on the restricted milking permission high concentrate treatment, that's the purple line, and those on the free milking permission low concentrate treatment, that is the yellow line. So because that is quite an important result for us, because if we can get a similar milking response to a very low concentrate level as opposed to a very high concentrate level, then it is a much more beneficial scenario from an economic perspective. But of course, we also have to look at the implications of the number of milkings per day, and that then as well, and the size of the herd. So the second piece of work that we're currently working with is examining performance of commercial farms operating automatic milking systems. We're doing this at present. Obviously, the installation of an automatic milking system represents a very significant economic investment. And first of all, conventional milking farmers that are considering changing to automatic milking, they have to understand what levels of performance that are achievable, under commercial operation, automatic milking scenarios. And secondly, it is good for automatic milking farmers to have a benchmark for their performance, to be able to benchmark against the potential of their systems and also against other commercial automatic milking farms. So we're currently identifying the KPIs that can be used for this and collecting looking at those KPIs then need to be assembled and interpreted. So we have at the moment 20 commercial automatic milking farms being monitored, and we have further 20 to start on. And the data from those farms is currently being summarized, and we're talking about the profile of the farms, the type of system or operation they have, for example, the calving spread, the grassland management, the concentrate supplementation. And then we're examining the milk performance data, drafting data, and management data as well. And we're also focusing on milk quality, cell count, and thermogenic bacteria as well. We have experienced some difficulties with that in the past, but now I think it is becoming resolved. The importance of hot water, the importance of using the right chemicals, and all of that that information has been transferred to people. And what's important here for us in a pasture-based system is relating to the management of the output or the system drift. In some situations, people may consider that they don't utilize the robot sufficiently at the shoulders of the ear, and therefore they introduce concentrate into the system to increase yield and that. But that has to be looked at economically, obviously, as well. So there are a few different points, I suppose, for future research. I mean, certainly from reading previous papers and that, recent papers and that, I mean, people would consider that the interaction between the animal and the person, the interaction between the data and the person, those things certainly need to be looked at further. Maybe also the influence of management variables on efficiency and economic performance definitely need to be looked at. variability in milk yield, milking time, milking interval of the cow, milking the slowest quarter faster, maybe to get an increased throughput, maybe trying to reduce the other preparation or attachment time, and maybe improving the economics of the system through identifying more or less profitable cows, and maybe better able to tell what cows to cull and that. So in conclusion, then a recent study here showed, or that was conducted at Moore Park, Palma Malina, a study of 2023. This showed or focused on the factors affecting the uptake of different technologies in on Irish dairy farms, and some of the positive attributes, or the positive characteristics, I suppose, were herd size. The larger the herd size, the more likely the people were to take on new technologies. The proportion of hard labour, if there was a lot of hard labour, agricultural education, a higher level of agricultural education, and also discussion group membership. On the other hand, the negative aspects for taking on technology were the age of the person and the number of household members. Presumably that meant that if there was greater number of household members, then there was less of a labour problem on that farm. So we all know robust and independent testing of equipment is very important before it's put out there. I suppose recently we would have seen in other areas as well of technology, the design should be underpinned by processes that involve the end user and also advisors and consumers, so that some piece of technology is just not put out there and the farmer or other people that would be using it not having any input into it. And we do need to work with farmers and operators to ensure that they understand and are comfortable with the technology. Thank you.
Excellent. Thank you very much, Bernadette, for an excellent talk. I'll ask you now to stop sharing your screen and we'll get Steve lined up for his session. Now I'll introduce our second speaker for today, second and final, Steve Jones. He is the Advisory Product Support Manager for De Laval, supporting the North American market specifically. He grew up on a dairy farm, and after graduating from Harper Adams University in the UK, he managed dairies on both sides of the Atlantic, including in the UK and the US. After moving to the US in 2004, he transitioned to become an advisor for milk quality and milking performance, joining De Laval in 2013. Steve is passionate about milking performance, especially on how vacuum levels, the milking machine and the cow interact to provide the best experience for the cow, while exploiting best economic performance of the milking machine. Working within De Laval, he has helped develop best practice in managing large herds in voluntary milking systems, which aim to improve automated milking performance. He also works with farmers to solve various milk quality challenges, where he looks for opportunities that focus on the dairy cow that can improve milk quality, milking machine performance, and bottom lines for dairy farmers. So Steve, I'll ask you to take the reins from here. If you can share your screen, please. Perfect.
Hey, well, good afternoon, good morning, everyone. John, everyone can see my slides. We're all good?
Yes, good to go.
Perfect, thank you. So thank you, John, for the kind introduction, and Bernadette for your presentation before, and the IDF for inviting me to speak. Today, I'm going to focus on milking labor. Now, for me, wherever there's challenges, there are opportunities. And John did introduce myself, but for me, why did I get here? For me, it's all about the cow. How do we make it better for her? You know, how do we make it the best possible experience? How do we keep her around longer? And also how the people are, because to me, it's the interaction with the person and how that person treats the cow is really what the experience is for that animal. And then when I'm not around cows, I'm with my family. I travel a lot, so I like to be home, and when I'm home, to be relaxing and smoking meats and cheeses and enjoying the outdoors. So realistically, I don't know. And then maybe I do take my work home with me if I want to smoke the meats. So when I look at this, and as John said, I look at profitability and the challenges. And what are the challenges? So for the main challenges that I see when I work with my dairies is their costs. Every one of our dairies is always talking about their costs and how can they reduce them. I think across the world, feed is the #1 cost. It's 53% in the US is what typically the cost of feed is. Behind that, the second largest cost is labor. In the US last year, it was right around 13% of total costs, but there's a really big range there. It ranges from right around just 9.7% all the way to 32%. So there's a really big range in that, and we have a big scope and range in dairy size too, and that's what drives that mostly. So we have farms as big as 10,000 cows milked on one rotary, down to small farms, 40, 50 cows that may be milked by an automatic milking system or a small parlor. Now, in the EU, it's right around 30% too, and you can see that the range that we have in the US fits into that too. And then the third largest cost that I always like to touch on, because I think it's one of the most important things that also takes a lot of labor, is replacements. Or as I prefer to classify it, cow expenses. Typically that's right around 10% to 17% of the cost of production in the US. And some studies showed in Europe was right around 15% too. But are these challenges in labor just related to cost? I don't think so. It's probably it's becoming one of the least parts of it, because realistically, we're seeing all these headlines, like dairy farmers force labor challenges never seen before. Labor shortages continue to plague farms. Why is labor such an issue in Eastern Europe? So it's a global event of what we're trying to do. But I'm going to bring it back to the US now as a more, where are we at? In the US, we have more legislation coming. So overtime legislation that we have to start paying overtime, which has not been seen before. So California, we have an 8-hour workday. Above that, we have to pay overtime. And then we also have above 40 hours, but it's not just California, it's Washington, it's Colorado, it's New York. All these states are introducing this, and it's coming more and more prevalent. It's only just going to become worse. And it's why the dairies are starting to look at what opportunities do I have to reduce my labor. So we see across the developed dairy world the implementation of batch milking through automatic robots. So it's either that or robotic rotaries to try and save labor. So the other challenge that we have is, once we've got the labor, are we keeping the labor? So we have our turnover, right? So when we're turning people over, that's also a cost. And when we look at the studies that are done, we have 150% of the total cost of somebody in replacing them. So if you're paying a milker $20 an hour, it's costing you $30 an hour to replace that person. So what is your turnover rate? Do you monitor that? Do you ever see what that is? But when we look at turnover rate on dairies, it's right around 38%, 39%. So we're right in that 40% range of what we're turning people over. But how does that compare? Well, actually, it's pretty good when we compare ourselves to the private sector, the rest of the private sector in the US, which is running right around 47%. But I still think that 40% is still a high number if we're going to build really good teams that can work. So why do they leave? I think it's pretty clear that most of us, or most people, move for more money, right? So compensation's the #1. What I find interesting is the relationships at the farm are the second largest reason that people turn over. So that whether that's the relationship with the manager or the relationships within the teams. So it's about 8% for a manager relationship and 7% for a team relationship. And then we have working schedules. Here in the US, we have a lot of immigrant milkers. And about 15 years ago, when I was first in the US, most of those milkers would come to the US. They wanted to earn as much money, work as many hours, send the money back to wherever their home was and go home to retire. We're seeing a change in that demographic, that people are coming to the US, they want to stay here, they're raising their families here. So instead of wanting all those hours, they want time for themselves. They have personal reasons. They want to take their kids to the softball. They want to go watch their kids at school and all those types of things. And then the last thing that is one of the key things is housing. Most of the task-oriented workers get housing as part of their package, and they deem that as either not good enough or, oh, they're looking for better. So these are the main reasons people leave. But really, I don't care about what those are, because for me, it's why do they leave your farm? Why are they leaving your farm to go somewhere else? You know, that's really what you need to know. You need to understand why the turnover is happening at your time. So when we look at this and we're looking at talking about labor, and it's the second largest cost, you know, do we have a human resource management team on the farm? Are you dedicated to that? You know, like I said, we're pretty good at managing our feed costs. We're pretty good at managing our replacement costs. We're pretty good at managing a lot of other costs, but do we truly manage our labor? You know, I think it's really important that we have a plan for this, you know, and how do we motivate people? It's not, there's lots of stuff out there about how we motivate and get people to do well. And specifying goals is number one. Where do you want them to be? How do you want them to perform? What task do you want them to perform? And how well do you want to do it? And then do you provide teaching to that? Like we talk about teaching and education and procedural drift and all those types of things, but are you providing training? And then once you provide the training and set the goals, are you providing feedback? You know, we all want feedback. You know, we all want to do well. It doesn't matter what tasks we do in our jobs. All of us on this webinar this morning or this afternoon want to do better. So we're looking for feedback. It was interesting that I was in a class, a leadership class recently. We talked about feedback and looked at some of the studies. And actually, there's a big disconnect from managers who think they give a lot of feedback versus employees that think they receive very little. And I think we can look at that in a couple of different ways. Is that if I'm a manager walking around or walking through the parlor and I see a milking technician not attaching a unit very well, and we go and we help them and we teach them and we believe we coach them to do a better job, but we're there for like 30 seconds and we're gone, we probably as a manager think that we gave that was feedback, but the employee doesn't think that. So taking time outside of the normal day to give feedback is really important. And then encourage employee input. You know, we all like to have the best working environment, and we all have opinions on how our employer could make it better. So how do we do that? I think it's really important that we ask for that and then impact it. You know, it might be something simple as, hey, it'd be really great if a couple of times a week we could have a food truck or food service come in at mealtime so that we can get something to eat, that we don't have to bring it all the time. You know, a lot of these dairies are remote, so having those things is really useful. I think there's one thing that we all hate to deal with, right? And that's addressing conflict. You know, conflict, good, healthy conflict is good, right? We want people to express opinions, but it can't turn into unhealthy conflict. Whether that's between two employees that aren't getting along and how do we manage that? Whether it's between the manager and the employee of, hey, that person's not performing the way I want. Are we giving the right feedback? Are we doing the right things to encourage them to be better? You know, addressing that conflict is super important to make sure we have a good team, because typically it's not the people having the conflict that leave, it's the peripheral people that are probably doing all the work that are leaving. And then communicate. We talk about communication. We have lots more media to communicate on. Often we're communicating so much, but do we even have time to stop and listen? So communicating well. And then we take that in another part of the dairies, is that there's language barriers. So we have typically a lot of Hispanic help in the US, but that doesn't come just from Mexico, it comes from Honduras. Maybe we have Portuguese from South America. You know, we have all these different languages that are on the dairy. So are we communicating in the right language? Is it understood, right? Because the different dialects mean different things. You know, as John said, I grew up in the UK, now I live in the US almost for 20 years. But sometimes I wonder if I'm still speaking a different language to my colleagues here in the US. So that's a little bit of the opportunities, or what I would call perhaps the soft opportunities we have on a dairy that aren't going to involve buying stuff. But I am going to take pretty much a hard right turn here, and we're going to jump from the soft stuff to the hard stuff, so the equipment. I do want to apologize. I work for DeLaval, so a lot of these pictures are going to have blue equipment in it, but please be mindful that all companies, there's a lot of different companies out there that provide similar solutions. So what are the opportunities? Well, I think they fit into 3 buckets realistically. So we have the automation. So we can automate and get rid of a job task. So we can apply pre and post teat dip. We can push feed up. We can automate some of the milking, right? So once the cups are on, we can automate detach, so we don't have to have the labor. Now, heat detection is one of the key time-consuming tasks, right? So having activity systems that can remove 4 to 6 hours a day of someone needing to watch cows in heat, you know, all those types of things really can help reduce task orientation, but they also increase the need of maybe a different style or different skilled person to manage a situation afterwards. From automation, we move to robotics, and Bernadette covered a lot of this, but we have machines that can actually work by themselves, and they can be more precise. So they can attach cups, they can prep cows, they can post-dip cows, and they're doing things much more precisely. So they're looking for a teat and they're looking to do something with that. But what we are also seeing is artificial intelligence and machine learning, and even deep learning now, right? Some of these technologies are already coming to the farm and enabling the dairyman to look at what their labor pool is to utilize it. So a good example of machine learning is a herd navigator. So that herd navigator is looking for other signals from a robot, and then it's determining whether the cow should be looked at if she's sick. It looked at to whether she's being in heat. And it also uses the fact that she knows if this cow came in heat on a 17-day cycle, it will adjust versus if a different cow is on a 21-day cycle. We have infrared technologies that look at the udder as the udder's going past, and then makes a decision whether that cow should be treated for mastitis. We have time-saving location devices that will allow you to find cows in a herd, and maybe in a 50, 60 cow dairy, that's not such a big deal, but in a 400 cow pen, knowing where to go find a cow is pretty important and pretty time-saving. And then we have milking point technologies that actually allow us to manage the milking completely automatedly. But the machine learns about the cow and will move from stimulation in a milk flow all in one at the time that it needs to be based on the cow. So we have all these technologies, but what does that mean? Now, we talked about labor shortage, and Bernadette talked a little about skilled and unskilled labor, or for me, is it a data manager or a task completer? That task completer is going to be the milker that we're talking about. And what are we competing with? It's just like the Amazon warehouse at the close town. Someone's going and completing a task that's repetitive. And I think here is where we really have some opportunities to use those technologies and be more profitable. So when we look at this, I think when we look at that type of stuff, replacing tasks that are pretty simple in the milking procedure, right? We can have pre and post spray robots. Whether that's in a straight barn or in a rotary, we can do this. So removing the operator from doing that, and if we do it twice on both the pre and the post on a rotary, we can perhaps lose 2 people from the milking string, which can really help profitability. So I was working with one of my customers about what was the decision making that we wanted to do. So when we looked at it, what would be the savings if we could replace 2 employees from each shift on the milking parlor? So in this instance, the guy was milking 3,000 cows on an 80-stall rotary. And you can see from the slide, he saved about 34 cents a hundredweight by replacing the labor with machines, which is a 30% saving in his milk harvest cost per year on that just on that team. And I think that's really significant when we can make those kinds of savings by putting in robotics and automation. But we talked a little bit about how do we reduce turnover? And if we're removing the simplest task from the milking procedure, then we actually create more work for the other employees. And when I go back to some of these farms that have invested in the technology, what I find is they don't lose all the people. Yes, they do reduce their labor some, but they don't lose it all. What they find is that they actually retain labor due to the fact they created a better working environment. So when we look at that, I think we need to think about is that maybe we only lose 1 person instead of the 2. So in this instance, we look at this in the same, I'm using the same farm here, that if we only lost 1 person, then the savings became 15 cents or 13%. Now notice that that's not half of what the savings were in this farm. And there's a reason for that. In my calculations, I always include a whole person. So if you need 12.2 people, then you need 13 people. So that's where that task comes in. But if we truly make a better work environment, what is the opportunity cost from that? So if we could reduce turnover from 40% down to 20%, what does that mean to us? Well, again, talking about that $20 per hour charge, then that's going to be around another 10 cents a hundredweight or 10% hundredweight cost savings. So even though it's not a total saving of the same as getting rid of both people, you've created a better work environment and people want to stay and work at your dairy. The other options are, we want to have good milking routines, right? We've talked a long time about we want to attach a milking unit to a clean, well-stimulated udder, right? Teat. But when we talk about large barns, we talk about procedural drifts because everyone says, how do I milk cows faster? And the mindset for the milker is, hey, I got to put that unit on faster. The faster I put it on, the faster she'll milk. But for those of us that are advisors, teaching them to slow down is faster is a very difficult concept for them to grasp. So, and the other part of that is that they're standing apart. They don't have that social aspect during their milking shift. So if we use some of the automation technologies that we have out there to provide the stimulation, we can actually put people together. So we can clean the udder, and then we can put the unit on. So the 2 people can talk, they can have a better work environment. And then we also provide a better environment for the cow because the cow gets the same treatment every time she visits the parlors. The unit that gets attached, the unit stimulates her, and then the milking process is fully automated through. So there was a couple of ideas, and I'm going to keep this short. There's a lot of things we can go into today, But as a summary, I just want to look at really the three biggest things that I think that are opportunities out there when you're looking at milk and labor. And number one for me is team building. How do you build a really good, efficient team that wants to come to work every day and does a great job of harvesting high quality milk for you? The second one is automation. How do we automate not only to save labor or reduce people, but to create a better work environment so people stay working for you? And then the last option is if your pool is really highly skilled labor and you don't have those task-oriented people available, how do you use the new technologies to create an environment where you're using the AI, where you're using machine learning, and where you're using deep learning? So that's all I have for you today. So thank you, and I'm going to turn it back to John.
Perfect. Thank you very much, Steve, for your interesting talk. So the next protocol for this webinar is to ask for your participation in a short poll that we'd like to launch right now to help gather your thoughts on some topics that we could consider for inclusion in our upcoming webinar. So I'll ask Annabelle now to launch that poll. It'll be a short 1-minute poll. And while you're completing that, we can move on to some questions from the chat. So we come to Bernadette first, if that's okay. Bernie, there's a question there around the SEC aspect of the automatic milking system. Perhaps you could give us some insight on the SEC situation with your research experiment, and also maybe offer some general advice on how to maintain a good SEC count in an automatic milking herd.
Okay, thanks, John. Yes, I saw that question in relation to SCC, and I know that in the past, and I mean, past references would indicate that in the beginning or the earlier years, there were problems with cell count in relation to the automatic milking. But I must say, since we put it in place at Teagasc, we never had any problem with cell count. We would always be running in past years. Now we would have been running at most of the year at less than 100,000. Certainly maybe very odd time up to 150,000, but that'd be only 1 or 2 occasions per year. Generally all the time less than 100, and most of the time very significantly less than 100. I think, I mean, looking at this, there would be a number of reasons, I think, that one could attribute to this. One is the consistency of cleaning. And we did a lot of work on cell count and teeth condition and cleanliness, hygiene of teeth in the conventional systems as well. So the reasons, I think, for having a very good cell count with an automatic milking system could be, first of all, the consistency of cleaning before the cluster attachment. And you do get a consistent cleaning with the machine, as opposed to maybe people in a conventional parlour that may wash one cow very well, or in the morning, and they may not wash them as well in the evening or whatever. So consistency, I think, is very important there. The second thing is, and maybe more importantly, is the consistency of the teeth disinfection. Again, in some conventional parlours, you see the droppers for the disinfection, maybe not working, some of them not working. The coverage of the teeth being done by the individual mightn't be great. Again, you have consistency of coverage with the automatic milking system. Thirdly, I suppose the cleaning of the cluster, and I think we found that to be very important, the cleaning of the cluster and the liners in between the milking of cows, so you're not transferring anything between one cow and the other. And lastly, and very importantly as well, the individual, the farmer, is able to look at the data and he can see the development of cell count as it goes, and he can take measures before he would take measures in a conventional parlour, because he can see it happening.
Very good, thank you. Bernadette, again, there's a few general comments there around, I suppose, the future of AMS systems, and there's a few questions there around, is it in the development of automatic milking robots in the box format, or is it more fruitful to focus on automation of conventional milking systems?
Well, I suppose, I mean, Steve is probably better fixed to answer that one, but I would suggest, I mean, okay, the automatic milking technology is very well developed at this stage. There were issues, I suppose, in the earlier years. It's there since 1992. It's now very well developed. The technology is well developed. I mean, there'll always be research going on and people thinking of new things, and there'll be, I'm sure there is going to be progress in the automation of you know, parts of the conventional systems as well, and there's nothing at all wrong with that. I mean, the important thing at the end of the day is that the farmer has maybe a couple of options, but that all options work well, you know, and that the technology works well.
Yep. Steve, I might open it up to you at this point as well, just to get your view on the future of milking larger herds in an efficient way from both labour and a capital perspective. Do you think multi-box AMS systems or automated conventional systems are more fruitful down the line?
I think the main driver in that, is both of us covered, really, is labor cost. The increasing cost of labor will equal out that cost of the automation and the robotics. You know, we have farms with over 60 robots in barns with 3 and 4 robots per pen on large sites, and we see large rotaries. So I think when I look at it as today, I think large rotaries are the most efficient way, or lowest cost ways to milk cows, but the farmers that can't find the labor are looking for automated milking systems. I had the pleasure of working with a farm that put in 22 robots in a batch milking facility, and the reason why is they don't have anyone coming to milk cows, and it costs them more. But if you don't have employees to milk cows, conventional doesn't work.
Good point. Bernie, I'll just come back to you for a final question around your experiment. I was wondering if there's an effect of seasonal supplementation on yield, and is it more fruitful to feed at certain times of the year versus the other? And secondly, there was, I believe it was one of the higher, one of the restricted treatments had an uptick at the end. I was wondering if you had any hypothesis why that may have occurred.
Okay, thanks, John. First of all, I don't have a hypothesis at the moment. We must interpret, go into the data further for that. We don't have that. But yes, certainly the supplementation at different times of the year is, I mean, it is more complex in a pasture-based system, and we have done some work before on that as well. We put in supplementation in early lactation, and we put in supplementation in early lactation, and we put in supplementation in late lactation. We had, I think it was about 20 days and about 200 days difference. Now we had, I suppose, we had about 2 and 4 kgs in early lactation, and we got no effect. No effect at all. And I mean, that has happened in conventional systems as well. With the grass, if the grass is managed well, the grass quality is good, at that time of the year, you won't get extra milk as a result. So it's, you know, one has to be very careful. Now, at the same time, of course, I mean, part of the reason for that is that the cow is partitioning off her body reserves as well, and one has to be very careful there, obviously because of the cow going back into calf again and the condition of the cow. But purely from a milk production point of view, we didn't get any extra milk at that time of the year. On the other hand, when we did put in, before we put in late lactation, we put in about 2.5 kgs and 2.5 kgs a couple of years ago, and we did get a response there, and the response was, I think, about 0.75 kgs per kg of concentrate.
Yeah. Good.
So it does differ at different times of the year. Yes.
Perfect. Thank you. We're gone a little bit over time, but I think we could get Steve to answer one more question for us before I hand back to Maria to sum up. Steve, I suppose in terms of prioritizing automations with the viewpoint of retaining employees long term, you know, where should people start with? What are the priority areas that milkers would look for in terms of maximizing their comfort and so on?
Yeah, I think you really have to think about that in two concepts, right? I talked about skilled labor. So if you only have skilled labor available that you need to pay more for, or you have to spend skilled labor money for task orientation, and I think you need to look at robotics and robotic facilities. The other option is like, how do you create a better work environment? So if you look at a rotary milking parlor versus a straight facility, you can really control the milkers. You can give them there's much more automation available for that you can create really good working environments. You know, a rotary parlor is more open, and the environment in the parlor is much nicer. So I think sometimes we look at those options and say, okay, well, I'm going to build like a double 10 parlor or a double 15 parlor to milk my cows, whereas a 30 stall rotary might be 20% more money, but you might be able to do it with 30% less labor and much better working environment. So I think those types of things, if you're building a new facility, are really important to be considering at this point.
Perfect. So I'd just like to thank both of our speakers again for their excellent presentations and their time in answering the questions. And there are some thoughtful comments also in the chat there that I'd encourage you to read. And thank you for your comment, Mark, on the servicing, etc. At this point, I'd like to sign off, and I'll pass you back to Maria for concluding remarks. Thanks very much.
Thank you very much, John. And I just want to take 1 minute more. So as you can see, we have now set up like a new IDF Mastitis conference that will take place in 2025, and it will be organized in Sweden. It will be jointly organized by IDF, the Laval, SLU, VAXA, VENGS, and of course we will be highlighting the latest research and development in milk extraction and other health. So please just save it in your calendar and spread the word if you know about this. I just wanted to invite you to check the publications that we have in our IDF website. You find some of them that are very relevant for this group. So check them. I will be keeping these slides. Maybe I will send them to you so you can click on them. And with that,